Two congruent circles are inscribed in a square of area, 64 square centimeter as shown in the figure below. What is the shortest distance between the similar circles and the center of the larger circle? Label B, O, C, and H. B is the tangent point of the similar small inscribed circles. O is the center of the larger circle. Join B, O, B, C, and O, C. Let R be the radius of the congruent circles and R be the radius of larger outer circle. Label point K, H, Q, W, and join K, O. This implies that OC equals the positive difference between the radius of the larger circle and the product of 2 and the radius of 1 the small similar circles. B, C equals the difference between 14 and the radius of 1 the similar inscribed circles. This is equals to line HT. But the area of the square equals to the square of one of its side length G, W, which is equals to 64 square centimeter. Take the square root of the equation to gives G, W equals to 8 centimeter. The product of 4 and the radius, R, of the congruent circle equals 8 centimeter. Divide the equation by 4 to gives that R equals 2 centimeter. W, T equals K. O equals the radius of the larger outer circle. H, W equals the difference between 14 and 2 which is equals to 12 centimeter. Thus, the radius R is equals to the difference between 12 and 6 which is equals to 6 centimeter. For question I, consider triangle B, O, C. B, C equals to the difference between 14 and 2 which is equals to 12 centimeter. B, O equals the shortest distance between the similar circles and the center of the larger circle. Using Pythagoras' theorem, we have that the square of B, O equals the sum of the squares of 2 and 12 which is equals to 148. Take the square root of the equation and we have that B, O equals the product of 2 and the square root 37 all in centimeter. Therefore, the required shortest distance between the congruent circles and the center of the larger circle equals the product of 2 and the square root 37 all in centimeter. For question 2. Since R equals 6 centimeters, the radius of the larger outer circle, its area, A equals the product pi and the square of R which is equals to the product 36 and pi all in square centimeter.